Welcome to this end-to-end demo showing application modernization into a multi-cloud world. My name is Claudio Tag, and I am a multi-cloud architect in the Enterprise Containers team. In today's demonstration, I will use Transformation Advisor to analyze workload in an existing WebSphere application server, select applications for potential migration to containers, migrate them using a CI/CD pipeline using microclimate and Jenkins, and finally create a multi-cloud ready application that I will deploy to IBM Cloud Private and move to Google Cloud. In Transformation Advisor, I can create a new workspace for an application server running an application called vBooking. The first thing that I will see is the option of downloading a data collector that will allow me to scrape data from the existing application server. I can choose the operating system running underneath that application server, in this case Linux, and download the data collector bundle that allows me to collect data around the applications running on that application server. Once I've run the tool, I can upload the data collected into the application server directly into the user interface. This generates a set of reports around the applications that were running in that deployment manager. I can select a preferred migration target, like Liberty in containers on a private Kubernetes cloud or on a public Kubernetes service, or WebSphere traditional in containers or VMs, or decide to select no preference to see all the possible options. In this case, I'm selecting Liberty on private Kubernetes. I can see that for all the files that the data collector has found on the deployment manager, a technical match and a set of issues have been identified. The technical match determines the complexity of the migration. For each of the applications, the migration complexity can either be complex, moderate complexity, or simple. A complex migration entails a code update and some incompatible technology features in the current migration target, in this case, Liberty. The type of issues are divided between the ones that need to be addressed before migration and the ones that can optionally be addressed after the migration. Let's have a look at a complex application like this default application EA file. Transformation Advisor has identified an incompatible technology when it comes to this migration. In particular, the use of EJB's enterprise Java bins is something that I need to address before I can migrate to WebSphere Liberty. The development effort is an estimation of how many man days are needed to fix the dependencies on enterprise Java beans. Other dependencies have been identified around the use of remote EJBs and Java EE security. 3 reports have been generated for me: a technology report, an inventory report, and an analysis report. In the technology report, lift and shift options are identified by Transformation Advisor. If I were to lift and shift this EA file, I could put it today in WebSphere traditional in a container or WebSphere ND into a virtual machine. If I wanted to move it to Java or Liberty Core, I would need to get rid of enterprise Java beans first. Let's now have a look at another application. The Flights app EA file has been deemed as moderate. No incompatible technologies have been identified, but code updates are required. In this case, the code updates regard the use of MBean and MXBean interfaces that needs to be made public. That is because the specification requirement was not enforced in Java 7, where these applications was running, but Liberty supports Java 8, and therefore these changes need to be made before deployment. The persistent XML file must be modified to be in a specification recognized location. Additional information are provided around the use of concurrent hash maps and a set of additional changes that can be made to make the application more lean. Let's have a look at the inventory report for this particular app. EA files, WAR files, and jar files are identified and listed in the summary view. In particular, Transformation Advisor gives you a breakdown of all the different elements part of the EA package and highlights which one of those are duplicated references, are dependencies on open source software that I might not be aware of, or unused but instantiated jar files. This gives me the opportunity of cleaning up this application before I migrate it to containers and to cloud, which will allow me in turn to reduce its footprint and its license requirements. More information around the use of servlets, JPAs, and JAX providers are provided in this report. Finally, if I click on the analysis report, I can have a view of all the business rules that Transformation Advisor has run and against which some flags have been raised. I can break down to the single rules that have caused those severe issues to be identified, show the rule results, and a rule help that let me understand what has been analyzed, where the issue has been found, and what is the resolution for that issue. That is valid for all the warnings, but also for all the rules that haven't flagged a warning or an issue, but I might want to go through in order to understand what Transformation Advisor has told me. Finally, let's pick a simple application. The frequent flyer app has been deemed as a simple one to migrate. Only 3 minor issues have been identified. This application can be migrated as is to containers. Transformation Advisor generates what we call a migration plan. In the migration plan, a bundle of artifacts that are needed for the migration itself are automatically generated by Transformation Advisor. That includes a server XML file, which is a configuration file for Website Liberty, a Docker file that I can use to build a Docker image, a Helm chart and a deployment YAML file that I can use to deploy that Docker image to Kubernetes, and a Jenkins file to create a CI/CD pipeline for automated build and deployment of that Docker file, and also a POM file for automated build of the application. If there are application dependencies, the EA file and the DB2 driver are required as parameters to pass into the pipeline for Maven to build the actual application. I could download the bundle and use the several elements in the bundle for a manual deployment, or directly from Transformation Advisor, link into the IBM Cloud Private CI/CD pipeline, microclimate, for automated deployment. If I click on Deploy, a request to commit these artifacts to a GitHub repository is made. And here I have my empty Git repository. And a way to link to the GitHub repository and the microclimate CI/CD pipeline is already provided. Also, I can choose what name to give to my microclimate project. Now I'm ready to deploy the project. Clicking Deploy pushes the artifacts to Git, creates a project in microclimate, and creates a Jenkins pipeline. I can also see that the deployment has started against Cloud Private. If I go into Git, I will see the artifacts just committed by Transformation Advisor. And I can now go to microclimate to see the new project being created. I've got other projects available in microclimate that were successfully built. The frequent flyer one has just been created and hasn't been built yet. Let's explore it. The project has been identified as a Java project and has been built as we looked at it. No validation problems has been found so far. And in microclimate, I can open the actual code generated by Transformation Advisor for me. I can see the server XML file that has been created for the migration and all the references to the old application libraries. Including the name of the app. I can see the POM XML file that Maven will need for the build, the Jenkins file, which will be used by the Jenkins pipeline, the Docker file to build a Docker image with all the information needed by WebSphere Liberty, and also some useful guides to migrate applications to Cloud Private or to Kubernetes using Microclimate and Transformation Advisor. If I want to deploy to Kubernetes, I might want to use a Helm chart, which again gets automatically built based on the WebSphere Liberty Cloud Pak, and also pre-populated through values that come from that migration bundle. The pipeline also gets generated automatically from me. This uses Jenkins, but it's also completely customizable. I can choose to deploy to different namespaces or different target clusters. Let's have a look at the default pipeline in Jenkins. Whilst we were looking at the application bundle, the first instance of the pipeline was already running. This is extracting the code from the Git repository, doing a Maven build, doing a Docker build, and finally notifying back Microclimate. Once the build is completed, I can go back to Microclimate and do a load test directly within the authoring tool. This will allow me to test the application locally before I deploy it to dev or to test and understand how it reacts to incoming traffic. When I'm satisfied with the quality of the application, I'm ready to push it out for further development and test. Once I've used Transformation Advisor to analyze my existing WAS workload and to select which application components are ready for migration, and therefore proceeded to migrate them using Microclimate and a Jenkins pipeline onto containers on Cloud Private, I can then use IBM Multi-Cloud Manager to manage those applications across different Kubernetes clusters based on IBM Cloud Private or on other Kubernetes managed and hosted services. In Multi-Cloud Manager, I can federate different Kubernetes clusters across different locations and public cloud providers, including Amazon Web Services, Azure Cloud, Google Cloud, and different flavors of IBM and Red Hat Kubernetes platforms. I can have a look at the different deployments across those clusters and resource consumption in terms of cloud provider type or region or purpose in an application development lifecycle. I can have a look at the number of pods, memory, CPU, and storage consumption. In Multi-Cloud Manager, I can define what we call compliance policies. Through compliance policies, I can create rules that get applied across all the different clusters in my federation. I can go very fine-grained, like limiting the amount of memory that gets assigned to specific pods across specific cloud providers, in this case AKS and GKE, or more coarse-grained, for example, creating specific roles or role bindings with access rights when it comes to deploy and operate applications across Kubernetes clusters. In this case, my EKS cluster is deemed non-compliant for this role. Therefore, I will stop specific deployments into this cluster automatically. I can have a look at the applications managed across these clusters and what they look like. This application has also been migrated through Transformation Advisor and Microclimate, but it's also been refactored into 3 separate microservices. Those microservices are deployed to an ICP cluster using a Helm package, exactly like the one generated automatically by Transformation Advisor. For these application components, I'm defining something called placement policies. Those policies are interpreted at runtime and determine where the application components get placed across the different clusters federated into Multi-Cloud Manager. I can go and manually change a policy to show how that determination can be changed in real time. In this case, the policy dictates for the application components to be deployed to a development cluster, which happens to be an IBM Cloud Private cluster. I'm going to go ahead and manually edit that policy to move this application component to a production cluster. A new determination is made, and the production cluster selected happens to be a Kubernetes cluster on Google Cloud. If I go back to my application topology diagram, I can see that the two containers for those two microservices are disappearing from IBM Cloud Private and are getting replaced by containers on Google Kubernetes Engine. This happens without downtime for the end user. From a monitoring perspective, Grafana dashboards get generated to follow components as they move across different clouds. I can see that for the components that are still on ICP, monitoring dashboards are provided, and new dashboards are created for the containers that have just appeared on Google Kubernetes Engine. Finally, Multi-Cloud Manager gives me a holistic topology view of all the containers and all the components deployed across the different clusters that are managed by the tool. And I can filter by cloud provider or namespace or application type or specific parameters to find containers deployed across different public locations and private Kubernetes clusters, independently from the technology running them. Thank you for joining me for this application modernization demo.